All right, ladies and gentlemen, we got some makeup work we need to do here. So here's what we would have been talking about in class on Monday if we did not need to go through and do those test corrections. We would have been working on sampling distributions day number 2. So I'm going to start with a couple of definitions. The first being an unbiased estimator. Here is basically what that is. It's a statistic used to estimate a parameter. In other words, it's unbiased if the mean of the sampling distribution is equal to the value of the parameter being estimated. In other words, if you were to have, say, that the mean of all of your different sample proportions, the mean of p hat, if that was equal to p, that would be an unbiased estimator. Or if you were to, say, take the mean of all of your individual sample means, if that mean was the same as your population mean, then that would be an unbiased estimator. Now, the flip side of that is you can also have what's known as an unbiased estimator, which is basically where the estimate does not match the parameter. Okay, so as an example here, what is the variability of a statistic and how can you reduce it? Here is what the answer to that would be. The spread of its sampling distribution. That would be the variability of a statistic, is the spread of its sampling distribution. Okay, so this spread is determined mainly by the size of the random sample. Here's what that kind of means for us, is that larger samples give smaller spread, which is good. It makes it more predictable. So the larger the sample, the smaller the spread. All right, so here we go with example time. We've got a couple different graphs up here. So the histogram above and left shows the intervals in minutes between eruptions of Old Faithful Geyser for all 222 recorded eruptions during a particular month. From this population, or for this population, the median is 75. So here's your actual frequencies. So the median of this would be at 75, so it would be about right in here. We used Fathom software, which is a software company, to take 500 simple random samples of size 10 from the population. You can imagine how long that would take if you were doing it by hand. Now, the 500 values of the sample median are displayed in the histogram above and to the right, so the results they pulled together for you are up here. The mean of these 500 values is 73.5. Okay, so in part 1, it says, is the sample median an unbiased estimator of the population median? And the answer here is no. The big reason being that because of this. So no, because the mean of the sampling distribution, which again, remember, was talking about the medians, so the mean of the sampling distribution, I'll do some abbreviating here for you, the mean of the sampling distribution of medians, remember it was a sampling distribution of medians, doesn't equal the population median. Because the 73.5 is not the same as your 75 that we know is the true median. Okay, so for number 2, it says suppose we had taken samples of size 20 instead of size 10. Would the spread of the sampling distribution be larger, smaller, or the same? In this case, it's going to be smaller. The reason being, larger samples would be more precise. So, smaller would in turn make the spread larger. All right, so in 3, what we're going to do is we're going to describe the shape of the sampling distribution, and it is pretty clearly skewed left. So as far as the S of SOX, very clearly skewed left. There aren't any apparent outliers. It told us that the center had a mean of 73.5, so it is centered at 73.5, and the spread, it ranges from 50 up to 85, so the spread is about 35. Okay, so next, this Fathom screenshot, which again is basically taking all of those individual samples for you, below shows the result of taking 500 separate simple random samples of 10 temperature readings from a population distribution that is approximately normal with mean 50 and standard deviation 3. So just as a reminder of the notation here, here is your mean, here is your standard deviation, which I'll write a little better for you. Here would be your mean, here would be your standard deviation, and recording the sample minimum each time. So this is a distribution of the sample minimums, looking just at those minimum points for each separate sample. So in part A, it asks us to describe what one individual dot represents. So each dot, which there are a lot of them, would represent a different sample, a different SRS, simple random sample, of 10 temperature readings. With the median, or not the median, with the minimum as the observed value. So each one of these dots represents the sample minimum. Now each separate dot is a different simple random sample with that minimum. Okay, so in part B, that's just to describe it. So for shape, I would say that this is fairly symmetric, which being a approximately normal distribution is what you would come to expect. For outliers, there really aren't any outliers here. For center, it looks like it's centered about 45, give or take. And for the spread, it ranges from, it looks like about 39.5 to about 51 or 50.5. So in terms of the range, that would be about 11 or so here, give or take again. Okay, so in C it says suppose that the minimum of an actual sample is 40 degrees. What would you conclude about the thermostat manufacturer's claim? Really, this can kind of mean two different things. Either the mean is way too big, so either the reported mean is way too big, or the reported standard deviation is way too small, because 40 would be way too far away to be an accurate representation of your sampling distribution. So if it's that far out, which remember 40 would be on this graph, 40 would be way out here, It's way lower than what you would come to expect. So if that's an actual sample that you're taking and you got 40 degrees, then I mean it could be due to just random chance, but most likely what's happening is either the reported mean is way too big, meaning that the numbers are way too large for that to actually happen, or the reported standard deviation is just way too small. It doesn't encompass enough to where you have enough data around 40 degrees. Okay, so that is it as far as notes go for what we would have talked about on Monday. So your homework, what you need to be working on is you need to work on page number 437, I believe. Let me double check for you. Yes, you are on page 437. You are working through numbers 9 through 19 odd. I will be posting an answer key to that. This assignment, I'm going to wait to collect until block day. So because I won't see you tomorrow, with Tuesday being a sub day, I'm going to go ahead and collect that from you on block day. That gives you Monday night tonight and Tuesday night to get that done. Now, you're going to also have homework tomorrow, so there will be a separate video posted over the notes for Tuesday's class. You will have a separate homework assignment to work on for that, but that is all for Monday night. All right, guys, have a good night. I'll see you on block day.